Bien, pues empezamos. Lo primero de todo, muchísimas gracias por acompañarnos en este nuevo webinar. Hoy vamos a estar hablando del análisis de código estático y concretamente de la herramienta CodeSonar de GrammaTech. Tenemos la suerte de que nos acompañen Alan Hall y Rob Dalton de GrammaTech UK. Hello, Alan. Hello, Rob.
Good morning.
Thanks for joining us today.
Hello.
Hello. Okay, I will start with a brief presentation in Spanish, and then I will let you start your presentation.
Thank you.
Ok. Bien, pues como decía, os voy a explicar un poquito cómo va a ir el webinar y voy a hacer una breve introducción en español y entonces ya daré paso a Alan y a Rob, que nos explicará, pues, Alan, la parte teórica, nos hablará un poquito más de quién es GrammaTech, qué es CodeSonar y entrará más en detalle acerca del análisis de código estático enfocado a sistemas embebidos y concretamente a aplicaciones con requisitos aplicaciones críticas en cuanto a seguridad con requisitos de functional safety. Finalmente, Rob nos hará una demostración de este tipo de análisis con CodeSonar. Esto nos llevará en total alrededor de 45 minutos. Comenta Javier que tiene el micro deshabilitado. Efectivamente, estáis todos con el micro deshabilitado. Al final, pues vamos a ser en torno a 60 asistentes y entonces, bueno, pues tenéis el micro deshabilitado. Podéis dejar todas las preguntas en el chat y las iremos contestando. Comentar que al final de la sesión os pasaremos una breve encuesta, os llevará 1 minuto contestarla y a través de ella podréis pedir el vídeo de esta sesión, que lo estamos grabando, y así pues si hay alguna cosa la podéis repasar. También podréis pedir a quien le interese una licencia de evaluación de CodeSonar, pues para que juegue un poquito más con el programa y bueno, pues entre más en detalle, que evidentemente en una sesión como esta pues no se puede entrar en tanta profundidad. Bien, para poner un poco en contexto, la mayoría de vosotros ya nos conocéis, pero bueno, pues comentar que nosotros somos CAPEL, nos dedicamos a la distribución de herramientas enfocadas al diseño de sistemas eléctricos y esencialmente electrónicos en España y Portugal. Llevamos del entorno de, bueno, camino camino de 30 años y estamos especializados en sistemas embebidos. Aquí lo que quería destacar es que la mayoría de vosotros nos conocéis pues porque llevamos líneas como ARM, Lauterbach, Seger, Zucken, XJTAG, etcétera. Seleccionamos muy cuidadosamente las líneas que llevamos y en ese sentido, desde hace algo menos de 1 año, pues nos hemos convertido también en los distribuidores de GrammaTech y creo que es importante para esta introducción explicar un poco cuáles son los motivos por los cuales nosotros pues, hemos firmado con GrammaTech, por supuesto, pero por los que creemos que este tipo de herramientas cada vez son más importantes, cada vez nos las estáis pidiendo más y esto también se refleja un poco en las estadísticas que hemos recogido del formulario que habéis rellenado para registraros a este webinar, que creo que son muy ilustrativas. Como digo, somos bueno, algo más de 60 personas, pero de más de 40 empresas diferentes y los números son bastante... bueno, esto para empezar habla del interés, pero ahora cuando dé algún detalle que hemos extraído creo que también es interesante para todos. Como digo, desde hace algún tiempo hemos detectado pues, un creciente interés o importancia por mejorar la calidad del software que desarrollamos y en muchos casos la necesidad de cumplir con normas de calidad o certificaciones. El primer punto que nos encontramos es la necesidad de cumplir con estas métricas de calidad, ya sea MISRA C, MISRA C++, Autosar, etc. De los que os habéis registrado, el 35% habéis comentado que ya tenéis que cumplir con alguno de ellos, pero es que otro 45%, es decir, bueno, otro 45% habéis comentado que aún no, pero que a corto plazo lo vais a tener que hacer. Es decir, que en un 80% habéis contestado que o ya lo estáis haciendo o tenéis previsión de hacerlo en el corto plazo. Siguiente punto que cada vez nos encontramos más es el tema de las certificaciones para Functional Safety. En este sentido, el 70% habéis contestado algo similar, es decir, o ya lo estáis haciendo o tenéis previsión de hacerlo a corto plazo. Pero estos serían los dos puntos, digamos, más básicos, al final, estas exigencias que cada vez se están viendo más, pero hay algunos más. Tema de las vulnerabilidades del código frente a ataques externos. Sistema de calidad interno, que cada vez pues, las empresas tienen mayor conciencia de, pues, intentan mejorar la calidad de sus productos, reducir plazos y reducir costes. Al final esto va de la mano y no he traído aquí la curva, pero también sería muy clara. Reducir o detectar este tipo de fallos en una fase temprana del desarrollo ahorra unos costes enormes. Si lo comparamos con lo que podría o lo que supone detectar estos fallos en última instancia cuando el producto ya está en el mercado, más allá de que en algunos casos puede ser incluso, pueden causar pues incluso temas peligrosos, ¿no? de seguridad. Pero esto sí que las empresas cada vez están más concienciadas e intentan mejorar la calidad de su software, que al final pues, es la calidad de su producto, el producto que venden en el mercado o que venden a un cliente concreto. Y, por supuesto, pues las exigencias de cliente. Cada vez los clientes están exigiendo más pues, estos parámetros o estos sellos de calidad pues, para asegurar que el código que están comprando como parte del producto pues cumple con una serie de normas o con unos estándares de calidad. Bien, con todo esto, con todo este movimiento del mercado, esta tendencia, nosotros pues, nos pusimos a analizar y al final llegamos a la conclusión de que queríamos necesitábamos encontrar una herramienta de este tipo y nos decantamos por CodeSonar. He puesto aquí algunos puntos que consideramos importantes, si bien Alan a continuación entrará más en detalle y, por supuesto, Rob nos los mostrará. En primer lugar, la detección de todo tipo de errores, la profundidad con la que detecta estos errores o hace estos análisis, la baja tasa de falsos positivos, que muestra una muy buena precisión. Segundo punto, la detección de vulnerabilidades, lo que hablábamos en inglés se separarían security y safety. en español pues hablamos siempre, bueno, con una sola palabra, ¿no? Seguridad, entendido más como vulnerabilidades o como seguridad funcional, en este caso vulnerabilidades del código. Tercer punto, la clara visualización de la estructura completa del código. Esto yo creo que también lo veremos con Rob y es muy, muy ilustrativo. Y el cumplimiento, por supuesto, de los temas que hablábamos, ¿no? de los estándares, diferentes estándares de calidad, que CodeSonar está preparado pues, para chequear todos estos estándares. Está certificado también según las normas que aparecen aquí y precualificado para la norma de aviación, que para los que estéis metidos en el tema, pues ya sabéis que funciona un poquito diferente esa norma y hay que cualificar la herramienta en el entorno en el que va a ser usado. Por tanto, esta herramienta está precualificada para ello. Y por último, que es capaz de interpretar binarios. Hay ocasiones en las que no disponemos del código fuente y CodeSonar es capaz de coger los binarios y hacer todo este análisis a partir de binarios. Por supuesto, esto está soportado para ciertas arquitecturas, arquitecturas de ARM, PowerPC e Intel. Si tenéis más interés en el tema, decidnos qué arquitectura estáis usando y miraríamos a ver si está soportada. Bien, yo no me voy a extender más, simplemente comentar que si después de este webinar os interesa entrar en más detalle, está disponible una evaluación gratuita por 30 días. La podéis hacer sobre vuestro propio código, es decir, que esta evaluación os servirá para detectar errores reales que tenéis, que a lo mejor tenéis identificados o a lo mejor no. Y que con la evaluación, pues por supuesto, hay tutoriales gratuitos que veréis que es muy, muy fácil, muy intuitiva de utilizar y, por supuesto, estamos nosotros y está GrammaTech pues, para daros todo el soporte técnico. Bien, yo por mi parte ya doy paso a Alan y os emplazo a que dejéis en el chat todas las preguntas que tengáis. Alan, it's all from my side. You can start the second part of the webinar if you
Excellent. Thank you very much. Just bear with me while I get that going for you. So, just a quick check. Can you see the screen? Okay. Let's hope so.
Yes. Yeah.
Thank you, Rob. Went dreadfully silent there for a moment. So good morning, everyone. Thank you very much for coming to the webinar today to find out a little more about GrammaTech and products for helping you build more secure, safe embedded systems. So just by way of introduction, at GrammaTech, we're really focused very much on helping people identify and understand and resolve software vulnerabilities, whether that be from a safety critical point of view or whether that be from a security point of view. We currently have two products on the market. The first you've seen a little bit about in the presentation so far, which is CodeSonar, which is a static analysis tool for source code and also binaries, which provides some interesting capabilities we'll explore a little more in the presentation. We also have Sentry, which is a relatively new product to the market. It builds on some of the technology from CodeSonar, but essentially it's looking at binary software composition analysis. So you might think of CodeSonar looking to uncover zero-day vulnerabilities as part of your development processes. Sentry, we're looking for end-day vulnerabilities in binaries that you might import into your development or in open source code that you're using. So there are two two divisions really in GrammaTech that work very closely together. The first we're really working with today, the software tools part of the business, but there's a very strong cybersecurity research division, which works with a lot of US and other countries, governments and defense organizations, a lot of groundbreaking research there, which actually feeds into the static analysis division. So for most of our customers, they're very much deploying, developing software products, typically concerned about safety and security, and ultimately need to make sure that they've got an efficient way of containing cost and risk. So looking to eradicate as many vulnerabilities and defects as they can early in the development cycle. I'm going to skip these slides very quickly, but there's a recording later, I think, so you can probably pause. But it just gives a little bit of context of the sorts of customers that we're working with at GrammaTech and through our distributor network. So just a few quick examples. In the automotive sector, one of our customers found a pretty nasty buffer overrun, but it was in an error handling function. So typically wasn't tested that often. So I think the takeaway message there is it's very easy with static analysis to cover more ground and test more thoroughly compared to actually typical dynamic analysis approach with a bunch of test cases to work with. In the industrial manufacturing area, one of our customers maybe got a little upset. They were using CodeSonar. They shipped a software update that crashed when they sent it out to their customers. But actually, from our perspective, I guess the good news, if I can put it like that, was they weren't actually running CodeSonar on one of the components, and it had a null pointer dereference in it. So, again, another takeaway, we hear some customers saying, yes, we're going to do this. We may run it periodically when we're about to do a new release. I think the takeaway here, though, is our most effective use cases are where you're building that in as part of your process, whether that be developers before they're checking in code, or as part of a continuous integration and deployment system that you may be delivering. For a medical customer in Asia, they had a test case that was behaving quite strangely, couldn't find the problem. Ultimately, we found an uninitialized variable as a root cause. And again, just that whole process of if you're doing this early and often, then you can save an awful lot of time in testing, debugging, and ultimately get releases out of the door more quickly. It's an RTOS vendor, found two pretty nasty security vulnerabilities in their libc implementation. They were using a competitive tool at the time, hadn't found them. And one of the strengths I think we find when we're doing technical evaluations and amongst our customers is, the depth of analysis we can do with our static analysis tools, is very high, and ultimately that matters. So maybe covering a little bit of ground here, so I'll get through this quickly. But static analysis, when you say that word or two words to people, can mean a lot of different things. For some people, that means all we're looking for is really to validate some coding standards, and we want to apply best practices. So you might hear, we want to become MISRA compliant in our development processes. We need to do that to build some sort of safety case. But it can also mean to other people, well, actually using formal method concepts to find nasty defects in the code, like the sort of buffer overruns, dead code, misuse of socket APIs, etc., etc. The point is, those defects obviously impact you financially, but also the quality and the security of the code. But it's all very well having really good static analysis, but ultimately you need to scale that to real-world programs and processes. Now, quite often in the embedded space, those code bases can be quite small, but increasingly there's more and more code going into embedded applications, and the technology we have is built to scale to ultimately millions of lines of code. And importantly as well, I think it's very important that when you're putting static analysis in place as part of a development process, I was having a conversation with a customer the other day, and their point was that the developers have got to like using it. It needs to help them, not get in the way, not make them jump over lots and lots of fences to be able to do their job. It's got to fit seamlessly into their processes. So if we look at static analysis, there are typically three, I guess, components that any designer of a static analysis tool will have to address. The first of them is the recall. How good is the tool at actually finding defects that exist in your code? The second is precision. So how noisy is the tool in terms of finding defects? So if it reports a lot of false positives, for example, you have an imprecise tool. The better the precision, the less false positives. The better the recall, the more true positives that you find and the less false negatives. And ultimately, it's got to run in a reasonable time frame. It is no use if you've got really good recall and really good precision if it takes 5 years to actually run the code. So one of the design philosophies of CodeSonar is very much about focusing on high recall. We're trying to find as many defects as we can in the code. We know the design philosophy of some tools is more to say, okay, well, get good recall, but precision is maybe a higher design factor, which is great because you reduce the number of false positives. The problem is you end up leaving defects uncovered in the code. So we find typically as part of an evaluation, and certainly amongst our customer base, we're uncovering a significant amount more of true positives in the code. So if we put static analysis in as part of our development processes, we all know it's much easier to fix during development when it's fresh in the mind of a developer. The longer it stays there and the longer ago that a developer was working on that code, the more difficult it is for them to kind of get their head back into what they were doing, how they were writing it, and just costs more money essentially to fix the defect. So obviously static analysis is somewhat language specific. Our core capability traditionally has been in the C and C++ areas. We've added now capability for both Java and C#. We also have the capability with some technology and standards to bring in other languages as well. But we can handle also binaries, which we'll maybe show you as part of the demonstration, being able to look into third-party libraries that you might be including as part of your development processes to improve the fidelity of the analysis for C, C++ static analysis. So moving on to CodeSonar in a little more detail. Language support, as we said, C, C++, Java, Android, C#. For binary analysis, we can work with Intel 32 and 64-bit. ARM v7 will be launching ARM v8 in the June timeframe. We also got access to PowerPC, and we can deal with other languages using the static analysis results interchange format. It is much easier to say serif, I think, than that long sentence. But there are tools on the market that support JavaScript, Scala, Kotlin, etc., and others, where they have the capability to provide a Serif compliant export, and we can import those into CodeSonar. So there's a consistent interface for tracking warnings, suppressing false positives or defects that maybe you're not interested in. And that's all done, hopefully, as you'll see, with a nice developer-friendly interface that gives really clear explanations and path information as to where that defect is and why it is that the tool is considering that to be a real defect. Importantly, CodeSonar is extensible, so there may be a specific check that you require that for some reason we don't cover. You can write your own custom checks within CodeSonar, and that can become part of your instance of CodeSonar. So very flexible in terms of reporting, but also extending the checks within the tool, and lots of tuning in terms of the checks that you want to run, and you know, clearly the less checks that you're running, the quicker the performance. So for example, if you don't have threaded applications, there isn't a lot of point in running the set of threaded checks that we have within CodeSonar. So this is a little schematic as to how we basically bring the code in to CodeSonar. If it's source code, we essentially wrap for C and C++, we wrap your build process and compilation process with CodeSonar. It monitors the way that you build your code. Your compiler goes off and does its thing. Ultimately, you go and link and you produce an executable. We take the output of our compiler, which happens to be the Edison Design Group compiler technology, and we produce a representation that effectively allows us to walk through some tree structures to try and find those defects. We store those defects in a warning database that we call a hub, and that can then be inspected through a browser interface or in IDEs like Visual Studio and Eclipse to actually understand and decide whether that's a real warning, and then you can basically triage them. You can set status on those warnings. That can be done through your continuous integration environment, can be done direct from the IDEs or a command line build. For binaries, that's a slightly different process. We literally point at the executable or the binary library and ingest that. For Java and C#, we're essentially going to ingest the bytecode to do the analysis there. So as I've said, workflow is typically we're looking at where we can integrate with IDEs or through the web interface. There's a bunch of dashboards and reporting and visualization that you have available to report. Look, here's the list of MISRA violations we have, or here's the list of buffer overruns that we've got. You can choose how you report that information. So some quick look at some sample checkers. Obviously, you know, we're compliant with the standards you can see on the right, and those defects are reported in the context of which CWE does this relate to, or which MISRA warning does this relate to. So you'll see that in the user interface. For Java and C#, similarly, probably more focused on the security issues. You know, the languages are meant to protect you a little more from some of the nasty things you can do in C and C++. But again, we're reporting the warnings in the context of CWEs or the OWASP rules and so on and so forth. As we've mentioned, binary analysis, currently for 32 and 64-bit, Intel and ARM7, PowerPC currently in beta, ARM8 coming in June. Very similar analysis for source code. where we're doing the library analysis, you don't inspect the warnings in the libraries. It purely is improving the fidelity of the source code analysis. For a full-blown binary analysis capability, the results are essentially given to you in disassembled code with some decompiler in C to help you understand the code path and visualization and so on. So as was mentioned earlier, we've got capability and often we're used in some sort of functional safety certification process. For a lot of functional safety standards, static analysis is a recommended or even mandated technology. We've essentially got functional safety kits and certificates available for various standards, such as ISO 26262, where we're qualified up to level 3. And as of version 5.2, which is a little ancient for us now, we're just about to launch version 6. That's available for all versions of the software. So the functional safety certificates are issued by Exida. There is in the kit, there is effectively a tool safety manual, list of known bugs that's updated, and so on. So all that's available to you. It's an extra cost option to the CodeSonar licenses. You may have your own processes. That's fine. CodeSonar has been used without the kit, but you have got the certificates available that you can download from the website. So I think I'm a little over time by about 3 or 4 minutes, but I'm going to stop my presentation now and hand over to Rob so he can show you CodeSonar in action.
Okay, thanks, Al. Let me just okay, here we go. Okay, hopefully everyone can see my screen correctly. Let me know if you can't. So let me just show you what I want to show you. So I'm looking here at the results that I've done for an analysis already, using obviously my browser to connect to the repository that Alan talked about during his slides. Just to make it clear, we can also drive CodeSonar through Eclipse and Visual Studio IDEs, so the analysis can be triggered in those environments, and the results can be reviewed within those environments as well. There's a little more screen real estate, obviously, in a web browser, so the web browser view is a bit more functional in the capabilities that we provide, and I'll show you some of those as we go through here. So when you first connect to your repository, which you would have installed locally somewhere on your network, as I've got it here on my laptop, you'll be presented with the list of projects that you've got. All a project really is a particular code base. Okay, so you can see here that I've analyzed many different code bases now. Okay, if we drill into one of these code bases or projects, and immediately beneath it we'll see the collection of analyses that I've done of that code base over time. The real point I like to make at this screen is there is some value to collecting all of these analyses. Firstly, it enables us to produce some charting and some reports showing certain key metrics over time, such as your warning count growth or your line count growth or reduction, as it may be. But also you might be using CodeSonar from an automated build system such as Jenkins, for example, where you might be generating analyses very quickly, daily, maybe more frequently than that. And therefore you as reviewers might not be able to keep up with the the output of all of the analyses. So that's another good reason why we hold on to all of these analyses, so that you can review them in your time, and then you can obviously delete analyses that you're no longer interested in, and you can configure CodeSonar to keep things by age or quantity as well. So if we go through to the results for the most frequent analysis, hopefully this is a fairly straightforward to understand table here. We're just listing all of the, well, some of the results. In fact, in this analysis, there was only 22 results of within this analysis, so they're all on show here. Each row in this table is a detected issue, and the columns, I hope, are fairly easy to understand what they're referring to. The point I really like to make over this screen is the key groups of checkers that CodeSonar provides, and there's 3 of them. So the first is a group I like to call crash causing and unpredictable program behavior problems, and this is probably the main category of problems that tends to interest CodeSonar users. It's many of the problems that you see in this class column, and many more besides as well. In this group, there probably are 150 or more different types of check. Excuse me. The second type of warning that CodeSonar provides, as we've mentioned a few times now in English and Spanish, are the various standards compliance families. And if we just quickly come over to the manual here, I'm not going to talk about them in any great detail other than to list, in this table, to show you how many different groups there are. So you can see the search standard, excuse me, we should see all the various MISRA standards, MISRA C 2004, 2012, 2008. I've scrolled past the AutoSAR standard, numerous different standards. The real point to make is not all of these different families of checks that exist within these standards are enabled by default. You have them when you buy CodeSonar, but by default they're not executed. The reason being is you may not care about doing an AutoSAR analysis or a cert analysis or a particular MISRA analysis. You just turn them on as you need them. Okay, so there are many additional checks to cover all of those standards as well. And then the final group of checks, as Alan said, is ones that you can write yourself. We expose the API that GrammaTech used to create many of these checkers that you see in the class column. That API is provided to you to go and use to create your own checks if there are any others that are important to you that aren't already in CodeSonar. So how does warnings look in CodeSonar? Well, let's take a look at one of these resource leak issues here. So importantly, we'll show you the snippet of code that contains the detected leak. And if we click on the warning details link here, we can see that this type of warning, what categories of checks it belongs to. So we can see it's a particular AutoSAR warning, a particular MISRA C 2012 warning, and many others, as you can see there. And we annotate this code here in 2 key ways to help you understand what the analysis is trying to tell you about how this resource leak occurs. Firstly, we highlight the specific execution path through the code that you need to follow to understand this problem. Now, in this issue at the moment, we've only got 3 lines of sequentially executing code, and as such, they're all highlighted as being important on the execution path. That will change in a moment when we look a little more detail at the issue. And then the other type of annotation are these event boxes that are attached to the lines of code where the commentary applies. This is our default presentation form and is normally enough for people to understand what the analysis is trying to tell you, so you can make your mind up about the issue. But if not, if it's not clear, you can click the all events link as I have just done. And in that case, CodeSonar will very likely show you extra explanation along the execution path to really try and make it clear what is going on, so you are left with a clear view of this issue. You'll see these annotations, these event boxes are numbered, so you'll just follow them through in numerical sequence. And I'm just going to step through these relatively quickly to really pick out some key abilities of the CodeSonar analysis for you. So the first two pair of events are commenting on a recognized allocator has been called. New and delete is understood for C++, obviously, but it's worth pointing out that we're not just sensitive to functions that manage memory, such as malloc and free and new and delete, but also functions that manipulate other kernel level resources, such as sockets, files, and threads. So wherever there's an allocation and deallocation model that you should follow for these types of resources, where your code doesn't follow it, then we're going to be able to report resource leaks or double freeze or any of the other different types of problems that can occur with resource manipulation. Now, event 3 is quite an interesting step through this issue, because the comment here is saying that string copy has no significant impact on our pointer of interest. Okay, and this is an interesting one because CodeSonar as a source code analysis tool likes or needs to see source code implementation of the functions so they can be analyzed and understood, and then the impact of those functions can be considered correctly by code that calls them. And yet I'm sure you're aware string copy is a good example of a function you normally only have in a binary form. You don't have the implementation of it, you just link to your standard C library to get your string copy. So the good question is, how has CodeSonar been able to understand the effect of string copy here? And the answer is that GrammaTech develop many behavioral models for standard library functions on a number of different platforms, so that where your source code interacts with these functions, even though we don't have the source code for these standard library functions, the analysis still understands, because of those models, how they behave, and therefore we can analyze how your code interacts with them, ultimately just to give a better quality of analysis, more true positives and less false positives. So really events 4 and 5 here are just highlighting how the analysis is interprocedural. We're able to find problems that span the entire scope of your code base. Some lesser tools, typically free tools, might have a more limited analytical scope. They may only analyze at the file level or even only at the function level, which is a very limited view of analysis. As I say, with CodeSonar, it's a whole program execution, and we can find problems that start at, any point in your code and traverse any path through any depth of call tree, somewhere ending up somewhere else entirely in your code base. We are sensitive to that, and we can detect them. And as we traverse these paths of execution through your code, we're sensitive to the data that is flowing along those execution paths as well. So what you assign to your variables and pointers, and how that data is aliased and assigned around to other pointers and variables. And that means that, for instance, when you come across a branching condition, as we have done here with this if statement, CodeSonar's analysis will only take viable paths through these conditional expressions based on what it knows about the variables and pointers that are being tested by that expression. So, for example, if the analysis has seen that somewhere you've said x is 1, and then later on you've got an if statement that branches based on whether x is equal to 1 or not, CodeSonar's analysis will only take the true path through that if statement because it knows at that point where you are calling if that X was 1. Okay, so we're completely sensitive to all of the data state of your program as well. And in this particular case, when the analysis took the false path through the if statement, which is why the else keyword is highlighted as being on the execution path, and we can see the simple issue. We remember to free our resource in the true path, but we forgot to do it in the false path. So if we continue to follow the path highlighting, we end up at the final comment, which says you've got a resource leak. Once you've reviewed this issue yourself, you can come down and assign your own status as you see fit, you know, whether it's true, whether it's false. You can assign it to different users if you've created them in our repository. And then you can save all of that information away in our repository with this issue. And as you can see from the change history here, which is quite lengthy on this example, if different users keep changing the status of the issue or any of the other characteristics, we'll record all of that information and at what point they did it as well. Just before I leave this issue, I just want to highlight how we're calculating code metrics if you're interested in them. So things like cyclomatic complexity, Halstead and McCabe metrics, we're generating them at different granularities, you know, procedural, file and whole program, but probably most usefully, you're able to set rules. For example, a rule could say, we don't want a cyclomatic complexity of more than 5 at the procedural level. We could run the analysis again, and all of your routines in your code base that exceeded a cyclomatic complexity of 5 would be flagged for, you know, as warnings for you to obviously review and simplify their implementations. And the last thing I want to show is the visualization tool. I've highlighted memory leak in the code snippet, and I can jump into the visualization tool and see where that function is called. I can navigate around my call tree. I don't have a particularly large call tree in this case, but it's quite useful for being able to see where this particular snippet of code might be called from within your code base to see if it's you know, maybe a more significant warning for you to deal with now rather than later. So that's the anatomy of a warning. A very important part of CodeSonar is being able to triage the warnings, which we've already talked about. And you can see a number of these warnings I've already assigned to myself with a true positive finding. They really are all true positive, by the way, if we went into them. You will get false warnings as well, of course. But the nice thing is, with this analysis, which I ran just prior to the webinar, you'll find that a lot of the issues have got priority state finding an owner of none, 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 and no owner, which is the default status CodeSonar assigns to a newly detected issue. But as I say, there's a number of issues already assigned to me. And that is because in an earlier analysis of this code base, I've reviewed some of these issues and set them as being owned by me and true positive. I never fix my demonstration code base, so every time I run the analysis again, the same problems are discovered, but any problems that I had previously assigned to myself as true positive will automatically have those same status in the latest analysis. So in other words, I know I don't need to look at these issues that are assigned to me in the most recent analysis because I've looked at them before. I only need to focus my attentions on the one that don't have any status. But even if you've not assigned status to issues in CodeSonar, you can rather nicely come to this drop-down list here that's got a number of ways of filtering the data. And we can say, for example, please just show me the new issues in this analysis compared to the history. And obviously, because I never change my code base, there are no new issues. But in your case, where you might be using CodeSonar to do a MISRA analysis, for example, which can sometimes result in many hundreds of warnings, it can be a lot for you to review, maybe on that first analysis that CodeSonar produces. And you might not be able to review all those issues before your team does some more development work, and you want to see what issues they've introduced. So this facility here that I've just showed, where you can say, just show me the new stuff, allows you to probably focus only on a much smaller collection of issues that are to do with the code changes since the last analysis. And you can still come back to an earlier analysis when you first triggered a MISRA analysis and review all those issues, in the time that you've got available to you. I just want to show you, hopefully, if I've got enough time here, just a handful of, well, I do have a couple of minutes. I just want to show you a couple of other issues here just to talk about other capabilities. So I mentioned that CodeSonar does a data flow analysis. Here's an example of a command injection issue. It's a very simple one, but it highlights the capabilities. So CodeSonar knows a number of calls that you may have in your code base, such as functions that are access files, or access the environment, or access the arguments passed to your program, or arguments that come over network connections. CodeSonar recognizes all of those functions over the box, out of the box, as it has done with getEnv here, which is why it's underlined in red. And the variable dangerous is underlined because CodeSonar now knows that holds data that has come from the environment, which may not be trusted. And then as dangerous is passed around our program, still being underlined, we can see when it is passed into this function and it becomes S, still underlined, indicating that CodeSonar knows it is a tainted data value. We can see that tainted data value then utilized in the system API call. And basically what this issue is showing here is that there's a potential command injection, a simple one, but a command injection where data is acquired from an external source and it hasn't been vetted and checked before that data is passed to a dangerous call in our program. If that vetting had occurred on this execution path, and CodeSonar is sensitive to various different types of sanitation and vetting, then this issue wouldn't have been reported. Okay, hopefully I've given you a good flavor of how CodeSonar presents its issues. I think it's time for any questions, perhaps.
Thanks, many thanks, Rob. I think, yeah, it's time for some questions. Also, if you want to show us as well the charts that you can build with this analysis, I think it's also interesting.
Yes, well, okay, so let me just show you. I talked about the trend chart. I'm still on vocal, aren't I? Yes, I talked about some trend charts earlier. I hope you can hear me okay. I can hear some background noise. So here's some examples of those charts and tables, so we can see the warnings over time. That's not the chart, is it? Let me come back here. So you can see the sort of the warning count over time of all the analyses that I've done in this code base. And usefully, these data points on the chart are, you can click on them to jump through to the analysis results for that point in time. So maybe you would want to do that if you saw a chart that had maybe a fairly level, consistent warning
think you've cut out, Rob. Can't hear you.
I think we miss Rob. Rob, are you still there?
It doesn't sound like it, does it?
Okay, well, anyway.
Maybe he'll come back.
Yeah, I think, Alan, there's a question, an interesting question. Sergi is asking, apart from Eclipse and Visual Studio, can it be integrated with some other IDEs?
Sure. Yep, I was going to pick that one up for you. So it kind of depends what you mean by integration. There is what I would call full integration with Eclipse and Visual Studio, where the warnings are presented in the IDEs in the same way that you've just seen them in the web interface. Some IDEs from some of the embedded vendors are built on Eclipse, and depending on how much they've broken Eclipse to make their IDE will depend on whether we work with them. So I don't have a Rob would be the person to give you the list of ones that we do work with, but Eclipse derivatives we can work with, and again you'll see the warnings presented. For other IDEs where you're launching the builds perhaps from the IDEs, we have some ways in working with that process with the IDEs. We don't present the results back into the IDEs, but we can work with them. So we have what we call a wizard that allows us to basically start that process, run the build from the IDE and monitor that process, and then at the end conclude the build. So it's possible. There's one here about where do the databases reside, wherever you want. So typically CodeSonar is deployed as an on-premise installation in your network. Whether you choose to host that in AWS or something, entirely up to you. We don't run CodeSonar currently as a software as a service and have our own cloud. So it's down to customers to decide where that database resides, typically somewhere on their network. And that allows people to conduct builds and analyses on lots of different machines in different places on the network and report those results back. So it could be several build servers that are reporting back. It could be individual desktops for developers that are reporting back, but down to you to choose where you deploy that.
Yeah, okay, thank you, Alan. I think there are no more questions. Okay, one more. Well, I think this was the same question that you already mentioned, and I think it was already clear, I think.
Okay.
Alan? Well, I guess that you don't need to store the all these, well, your code and all this analysis in the cloud. You can do it in your own system. So
I would say refer to your in-house legal team as to the legal context and things like that. If you're deciding to deploy CodeSonar in the cloud, as I say, it is not something that we do.
Yeah. Okay. Okay. So if there are no more questions, someone's writing. Okay. Okay. Thanks.
Thank you.
Thank you. Gracias, Gerard. Okay. So gracias a todos por asistir. Al final, bueno, nos hemos ido a la horita y yo creo que espero que os haya parecido interesante. Como os he comentado al principio, os enviaremos una pequeña encuesta Esta sesión, también he comentado, la hemos grabado en vídeo, así que la tendréis disponible. Y nada más, agradeceros vuestro tiempo, agradecer también a Alan y a Rob, que lo hemos perdido, pero por suerte ya había acabado su demostración. Y nada, os emplazo a próximos webinars. Thanks, Alan, for your time. Please, thanks also Rob, that he's not with us at this moment, but thank you for your presentation. And yep, talk to you soon.
Thank you.
Thank
Bye.
you. Bye.